Quadratic formula, find the solution set. So if you remember what was the quadratic formula, guys, let me help you. When we have the discriminant, which we may call delta, b squared minus 4 times a times c, and we said that if delta is greater than 0, we have two real roots. If delta is equal to 0, we have one real root. And if delta is less than 0, we have complex roots. To find these roots, we use the formula. The x is equal to negative b plus minus square root of b squared minus 4ac divided by 2 times a. Delta is b squared minus 4ac. So in our question, and by the way, how is our standard form? Ax squared plus bx plus c is equal to 0. Now, in our formula and in our question, when we look at x squared and x squared, so coefficient of x squared is 1, which is in our question a is 1. And before x, we have b, which is in our question 3. And the constant term, it's here, c is equal to negative 4. So if we use the b squared minus 4ac, it will be 3 squared minus 4 times 1 times negative 4. So 9, negative and negative will be positive, 4 and 4, 16, which is equal to 25. Since 25 is greater than 0, we have two real roots. We have two real roots. By the way, we can continue now. The first real root is equal to negative b, b is 3, minus root 25 divided by 2 times a, 2 times 1, which is 2. So result will be negative 3 plus 5 divided by 2. 5 minus 3 is 2. 2 over 2 is 1. And the second result, if I call this is second root, this is first root. So negative 3 plus root 25 divided by 2, which is equal to negative 3. Actually, here it was minus, so I put plus 5. So let's say this is plus, and let's say this is minus. So negative 3 minus 5 divided by 2. So it will be negative 3 and negative 5. It will be negative 8. Negative 8 divided by 2, negative 4. So the solution sets x is equal to negative 4 and x is equal to 1. Or we can write in a curly braces. Solution sets are negative 4 and 1. How can we check is there any mistake or not? To check this, just put it, plug in. X is negative 4, so put it here. Negative 4 parenthesis square plus 3 times negative 4 minus 4 is equal to 0 or not. If it is 0, you are right. So 16, negative 12, negative 4. So it is clear that 16 minus 16, which means that it is equal to 0. So we satisfy. Similarly 1, if I put it 1 squared plus 3 times 1 minus 4 is equal to 0. I will check this. So 1 plus 3 minus 4 is equal to 0 or not. I will check this. 1 plus 3, 4. 4 minus 4, 0. 0 is equal to 0. Yes, it is. So this is solution. And do we need to check? No, we don't need. Just to be sure, did we do any calculation mistake or not? Okay. Now, what about this? So A is in this question 6, B is negative 2, and C is 0. So B squared minus 4AC will be negative 2 parenthesis square minus 4 times 6 times 0. So this will directly 4 minus 0, which is 4. Since this is 4 greater than 0, we have two real roots. Actually here, these real roots are rational roots. or directly integer roots. So this is perfect square 4, so it will be directly roots, the integer roots. It's not important. Just let us find them. So the first root is equal to negative b minus root delta over 2a, which means negative b. So negative 2 minus root 4, 2 times a, which is 6. So if it will be positive 2 minus 2 divided by 12, which is 0 over 12, which is just 0. If I haven't done any calculation mistake. Let me check it quickly. Negative 2 will be positive 2 minus root delta, right? So it will be 2, that's correct. What about the second root? If I call this is first one. So negative b plus root delta over 2a same. So negative 2 plus root 4 divided by 2 times 6. So it will be 2 plus 2 divided by 12. So 4 over 12. 4 over 12. So 4 over 12, when we simplify, this is 1, this is 3. Result will be 1/3. Let's check to be sure. Negative b, negative, positive 2, and 2, 4, 2, 6. Yeah, that's correct. How can I check is there a mistake or not? Or forget about the quadratic formula. Can I use normal factorization to solve this question? Yes, 2x common parenthesis, 3x minus 1 is equal to 0. 2x is 0 or 3x minus 1 is 0. So x is 0 or x is 1 over 3. Why? 3x minus 1 equals 0. So x is 1 over, yes, as we did. So this is by using the factorization. The other by using the quadratic formula. And that's it. Let's continue. Now a is 2, b is 7, and c is 3. So b squared minus 4ac will be 7 squared minus 4 times 2 times 3. So 49 minus 4 and 2, 8, 8 and 3, 24. So it will be 25, which is greater than 0. We have two real roots. So the first root will be negative b minus root delta over 2 times a. So negative b, which is 7, minus root delta, which is 25, 2 times a, which is 2 times 2. So it will be negative 7 minus 5 divided by 4. So negative 12 divided by 4, which is negative 3. This is first root, let's say. What about the second root? Second root, guys, directly you can say that negative 7 plus, just in front of the radical, change it. Well, since the formula is using negative b, plus root 25 divided by 2 times 2. So it will be negative 7 plus 5 divided by 4. So negative 7 and 5, negative 2 divided by 4. So it will be negative 1 over 2. So x2 is negative 1 over 2. So what is the solution? Solution is negative 3 and negative 1 over 2. That's it. Now, quadratic formula again. So this is now A, this is now B, this is now C. So B squared minus 4AC means 5 squared minus 4 times 6 times negative 6. Okay? And then 25 plus 4, 6, 6, or 6 and 6, 36 times 4, 144. And it will be, if we add 5, 4, 9, 2, 4, 6, 169. Since greater than 0, we have two real roots. To find these two real roots, the first one, if we say minus b, which is 5, minus root delta, which is 169, 2 times 8, which is 6. So result is negative 5 minus 13. We know that square root of 169 is 13, 12. So it is negative 18 over 12. If we simplify this by 6, negative 3 over 2 is our first root. Now what about the second root? So negative 5 plus root 69, 169, 2 times 6, which will be negative 5 plus 13 divided by 12, and it will be positive 8 over 12. If we divide by 4, 2 over 3. So x2 is positive 2 over 3. So solution set will be negative 3 over 2, comma, positive 2 over 3. That's it. I hope you understood everything. There is no problem.